So this is the method that I use for balancing chemical equations. In the next videos that I have in my playlist, I have used this method. Of course, I had to do small modifications for some of them. You can see it more of a guidance where it's going to walk you to the correct path of getting the correct answer. But you just have to have an open mind too whenever you're applying this method to other chemical equations. Most likely you're going to have to make small modifications, but that's okay because at least you have some type of guide, some type of path that is going to get you to the right answer. So my first step is to determine how many atoms, and depending on the chemical equation, at times it's going to be atoms and polyatomic ions that you have present. So you start out by that, determine how many atoms you have or how many atoms and polyatomic ions you have present. The second step is to identify the loner, and that would be the one that is also called the pure element, and it's the one that stands by itself. And that is one that is not part of a compound. And keep in mind that since there's so many different types of chemical equations, sometimes there's no loner. And other times there can be more than one loner. The third step is to identify the 1:1 ratio, also known as the pair element. And that would be the element, or at times the polyatomic ion, that appears one time on the reactant side and one time in the product side. And it does not matter if the subscripts are different, and they can be part of a compound. So that's how you identify the 1:1 ratio. The fourth step is to start with the largest 1:1 ratio, also known as the pair element, as mentioned in step 3. And this is the element that has the largest subscript. There will be times where you will have elements that have the same subscript. So at that point, sometimes it's better to start with one specific one. Other times, it doesn't matter with which one you start. By watching the next videos and not just watching one video, you will have a better idea of what I mean by this here. The fifth thing is to, if possible, of course, to end with the loner. Sometimes you'll just have one loner, and sometimes you will have more than one loner. Some extra reminders are that in certain situations, try to use low coefficient numbers when balancing a chemical equation. Now, that's not to say that that's going to happen in every chemical equation, but at least try if possible. If not, then try something else. Another reminder is that if a polyatomic ion appears on the reactant side and on the product side, that would be your 1:1 ratio, keep it together as a single unit, or also known as a group, and do not break it apart. Now, if a polyatomic ion appears only on one side of the equation, regardless if it's on the reactant or product side, if it's only appearing one time, then you have to break that polyatomic ion into individual elements. And I have multiple videos for that as well. The fourth reminder is that if possible, balance the polyatomic ions early in the process of the chemical equation. And the last reminder is that after balancing an equation, if necessary, simplify the coefficients by first dividing them by 2. So here's the overview of what I just went over.